Hello, I'm Mrs. Vaishali Samant. I invite you all to Saraswati tutorials. If you like my videos, please share and subscribe those videos. Today I will solve some more problems on derivative by first principle. Y is equals to x sin x. So fx is x sin x. F of x plus h will be x plus h sin of x plus h. dy by dx is limit h tends to 0 of f of x plus h minus fx upon h. That is limit h tends to 0 of x plus h into sine of x plus h. This value we are substituting minus this upon this. I will not use formula for this. I will multiply x into this, h into this. X into this and x terms containing x I will take together. Sine of x plus h minus sine x and h sine of x plus h separate divided by h. Now I will separate this upon this. When I will do this upon this, h will cancel and I will get sine of x plus h. And this will be x here. You use sin c minus sin d formula. Of course, limit is there. Sin c minus sin d is 2 cos c plus d by 2 sin c minus d by 2. So you will get this. But here you will get h by 2. This minus this by 2 is h by 2. But here only h is there. So I will divide and multiply by 2. And now this and this as h tends to 0, it will become 1. This 2 cancels with this. And if you put h is equals to 0, you will get cos of 2x upon 2, that is cos of x. Of course, x is outside. X cos x. And this h is 0 if I write here. H is 0. So it will become sine of x. Now, for practice, you solve these problems, you try by first principle. Derivative by first principle, answers are given. Here, when you will find out f of x plus h, you will get x plus h whole square. You expand it like this. Take terms containing x square separately. Hx here, of course. And simplify. This you will get answer. Next problem, purposely I will take y is equals to x square tan x. Fx is equals to x square tan x. F of x plus h is x plus h whole square into tan of x plus h. Write formula. Substitute f of x plus h minus fx here divided by h. Expand this. X square plus 2hx plus h square. Keep it as it is and x square this. Of course, limit is there. Collect the terms containing x square. X square term will be tan of x plus h minus tan x upon h. Middle term will be 2x h tan of x plus h. I am separating h. I am dividing h by each term. And this term will remain. This already we have taken with this. So h square tan of x plus h upon h. Now here h cancels with this. Here h cancels with this. One h will remain. Now I don't know formula for this tan. So I will write in terms of sine and cos. Before that I will take h outside. This is sine of x plus h upon cos of x plus h minus sine x upon cos x. Here we will get 2x tan of x plus h. If I will write 0, it will become tan x. And if I will write h 0, 1 h remains here. So entire thing will become 0. Take LCM here. This is outside, limit is there. This into this minus this into this. This is ulta formula for sine of a minus b. Sine a cos b minus cos a sin b. Sine of a minus b. A is this, b is this, a minus b. So x plus h minus x you will get here. And that means x cancels, you will get sin h here. X square upon h, still limit h is to 0 is there. Sin h upon h is 1. And in remaining terms you write this term as it is. Remaining terms you write h is equals to 0. So x square and here cos x into cos x, cos square x, 2x tan x. So x square x plus 2x tan x will be the answer for this. Similarly, you can solve previous problem. All these problems I am solving by derivatives by first principle. Y is equals to a raised to x. A is constant term. Fx is a raised to x. F of x plus h is a raised to, replace x by x plus h. So dy by dx is equals to dy by dx is to limit h tends to 0 of f of x plus h minus fx upon h. Substitute value of f of x plus h. This you substitute upon h as limit h tends to 0. This is nothing but a raised to x into a raised to h. So a raised to x, if I'll take common, inside the bracket you will get a raised to h minus 1 upon h. And you know, derivative of this is limit of this as h tends to 0 is log a. So it will be a raised to x log a, of course to the base e. You have to remember this formula. D by dx of a raised to x is a raised to x log a. You have to remember. Similarly, I will find out y is equals to e raised to x by first principle. This is from 12th standard syllabus, this part. Because this can be asked for 12th standard by first principle. Y is equals to e raised to x, fx is e raised to x, f of x plus h is e raised to x plus h. Formula for dy by dx. Substitute f of x plus h, fx you substitute divided by h. This is e raised to x into e raised to h. So e raised to x you take common, you will get e raised to h minus 1 upon h, e raised to x outside. This is nothing but log of e to the base e raised to x is there. Log of e to the base e is 1. So answer is e raised to x. So you have to remember this formula. D by dx of e raised to x is e raised to x. You have to remember this formula and this formula. Y is equals to log x to the base e. Fx is equals to log x to the base e. F of x plus h is log of x plus h to the base e. Write formula for dy by dx. Substitute this from here. 1 upon h I will take outside. Log m minus log n is log of m upon n. I will simplify this. This will be limit h tends to 0 of 1 upon h log of this upon this is 1. This upon this is 1 upon x h. You know formula. Limit h tends to 0 of 1 plus kh raised to 1 upon h is e raised to k. So this will become, this is just like k here because h tends to 0 is there. So it will be h, if will bring here, this 1 upon h will go here. This 1 upon h will go here and you will get formula. Or you can write if you want 1 upon h here and cancel out this. So this is e raised to 1 by x. So log of e raised to 1 by x by theorem, 1 by x will come here log e. Log e is 1. So it is 1 upon x. So derivative of log x to the base e is 1 upon x. You have to remember this formula. One more problem from derivative by first principle. Fx is equals to, if quotient comes, how to do? By first principle. X plus 2 upon x plus 1, find derivative by first principle. Fx is this. F of x plus h, replace x by x plus h here. So you will get here formula, substitute here, write formula here. It will be 1 upon h outside. This will be x plus h plus 2 upon x plus h plus 1 minus this. Take LCM, this into this, minus this into this. 1 upon h is there, limit h tends to 0 is there, 1 upon h is there, multiply these two. So you will get all these terms. And if you will multiply, and be careful, put bracket for a bracket here and negative sign outside, so all will have sign changed. And if you will simplify, you will get here minus 2h and h, all other terms will cancel, so minus h. So minus h upon h cancels, minus 1 upon, you write h tends to 0, you will get x plus 1 whole square. So for answer for this is minus 1 upon x plus 1 whole square by first principle. And you can try this problem, the answer is given here. Now I will stop here and next time I will continue this topic.